طيب بسم الله الرحمن الرحيم. We'll continue doing some exercises related to the area problem. I have these two functions. As usual, we'll try to graph the functions. So I have what? Now I'm trying to do exercises from the old exams questions. I have a collection of old exam questions related to the area, so I'm trying to do. This is y equals x squared. Yeah, very clear. And this one is what? It's x squared plus 4. So it will do something like this. Yeah, this will go this. This will do something like this. So I'm talking about the area between them, which is this area, which I think is an easy one. But I need to find this point and this point. I mean the x values. And the strip will be, this is upper minus lower all the way. How to find the point of intersection? Let me call it y1 and y2. Points of intersection. I will equate the two functions, y1 equal y2. So I'm getting what? 2x squared equal 4 plus x squared. So I'm getting x squared equal 4. So x plus or minus 2. So this is minus 2 to 2. So my area is minus 2 to 2 of what? I have the upper. The upper is this one. So it's y2 minus y1. y2 minus y1 dx. That gives me minus 2 to 2. y2 is what? 4 plus x squared minus 2x squared, which is y1. That gives me 4 minus x squared dx from minus 2 to 2, which is what? 4x minus x cubed over 3 from minus 2 to 2. That gives me 8 minus 8 over 3 minus 8 plus 8 over 3. That gives me what? 16. 8 minus 8, 16 minus 16 over 3. 3 times 16, that is 48. Minus 16 over 3. And that gives me 32 over 3, which is, yeah, not difficult. Easy. Okay. Find the area of the region bounded by the curve y equal in x. X equal minus 1 minus y squared. Okay. And y equal 0 and y equal 1. Okay. Let us graph it. Always you need to graph the function. I think it's better to graph the function. Y equal in x. This is the parabola. This is minus 1. Okay. And you have y equals 0. This is y equals 0. The x-axis. And you have y equal 1. This is y equal 1. So I'm talking about what? I'm talking about this area, which is very clear to me. I will do it in terms of y. I have the strip this way. And it is from 0 to 1, the integral. So the integral, so I have, let me call the, I need to be careful. I write it in terms of x now. So I have x equal e to the power y. That will be my x1, that will be my x2. So I have x1. So I have the area will be the integral from 0 to 1. It's very clear. x1 minus x2 dy. That from 0 to 1, ey minus 1 minus y squared dy. And that will be integral from 0 to 1, ey plus 1 plus y squared dy. Okay. That gives me what? Ey plus y plus y cubed over 3 from 0 to 1. That will be e plus 1 over 3 minus b to the power 0, which is 1, 0, 0. So that gives me e plus 1 over 3, which is this. Okay. The area of the region bounded between the curve y equals square root of x and y equal half x. Yeah, square root of x is this one. Half x will be this one. So I have this is y1, this is y2. Very clear the strip will be like this. So I need this point. How to get that? I equate the two. Y1 equals y2. So I have a square root of x, half x. 2 square root of x equal x. So I have 4x equal x squared. So I have x minus 4 equals 0. So this point will be 4. Okay. So I have the integral. It's from the area will be from 0 to 4. I have y1, which is the square root, minus the line. So I have y1 minus y2 dx. That will be from 0 to 4. Square root of x minus half x dx. Square root of, we have what? 2 over 3, x to the power 3 over 2, minus 1 over 4 x squared. That from 0 to 4. Do the calculation. That will be what? 2 over 3 times square root of 4, which is 2 cubed times 8, minus 16 over 4, which is minus 4. So that will be 16 over 3 minus 4. So you have 16 minus 12 over 3, and that is 4 over 3. This. Okay. The area between the curves, y equal x minus 1 square and y equal minus. Okay, so this is parabola, which is the vertex is what? Between 1, it's 1 and 2. The vertex is 1 and 2. And the parabola open upward, open up. And this one, a parabola, this is 1 and 2. This is a parabola, which is 1 and 1, 1 and 1. And it's open downward. And it passes through this here, like this. Okay. Given the area between the curves for between 0 and 3, up to 3. This point is what? This is 0. I think this point is 2. I want it up to 3. Here, up to here. I'm talking about this area. And the area between them. This is the area I'm talking about. Okay. So it will be the area. Always if I do the strip, this one minus this one. This will be the upper one. So I have y1 and y2. And he told me between 0 to 3. So I have the integral from 0 to 3. And I have what? y1 minus y2. dx. Because this is the upper one. Okay. So let me do the calculation. That will be what? 0 to 3. X minus 1 squared plus 2. Minus. So right away multiply by minus. That will be plus x minus 1 squared minus 1. dx. Yeah, let me open the square. X squared minus 2x plus 3 plus x square minus 2x plus 1 minus 1 gone. No. Dx. Then give me what? 0 to 3. 2x square minus 4x plus 3 dx. That give me 2x cubed over 3 minus 2x square plus 3x from 0 to 3. Substitute the 3, 27 over that will be 18 minus 2 times 9 is 18 plus 9 minus 0. Since I'm minus 0, so that would be 9. So this is okay. The area of the region bounded between these two curves from x equal minus 1 to x equal. Okay. What are the curves? I have 5 absolute value of x, which is this. What is this? This is the parabola, the lower half of the parabola. Something like this. And they want it from x equal minus 1. This is minus 1 to 1. So I'm talking about this area. What about this area? From x equal minus 1 to 1. I want the area between them. Yeah. So always I have this. This will be the strip. Okay. So now what will happen? Yeah. Let's be careful. Here I have y equal 5x. And here I have y equal minus 5x. Okay. So I can split it into the two parts. I say, let me do this one as A1 or A2, and this is A1. So A1, so my area will be A1 plus A2. So my A1 is what? Is the integral. Yeah, because of the absolute value. You need to split it, or you can make it, yeah, this minus this, and then you deal with the absolute value, or you can split it into two areas, minus 1 to 0 of the first, which is minus 5x, minus this, which is square root, plus. How to find this? Yeah. Yeah, it's half. Yeah, it's quarter circle. Okay, so this is will be minus 5x squared over 2 minus 1 to 0 minus 5x dx plus minus 1 to 0 this. I know this is quarter circle, so this is 1 over 4 by, it's not by, it's 1/4 by r squared, which is 1 square, and this one is minus 5x squared over 2 from 0 to minus 1, which gave me what? Minus 5 over 2 plus plus pi plus quarter pi. Wait a minute. Yeah, this is from minus 1 to 0, plus 0 to minus 1. So this one will be what? It will be 0. Yeah, it will be 5 over 2. plus pi over 4. Second area will be the same, but I can do it calculation. A2 will be from 0 to 1. Same thing, I have 5x minus this, I have plus square root 1 minus x squared dx. So that gives me 5x squared over 2 from 0 to 1 plus 1 over 4 by 1 square. I split it into 2 parts. And this will be 5 over 2 plus pi over 4. So it will be my area will be A1 plus A2, which is 5 over 2 plus pi over 4 plus pi over 2 plus pi over 4. And that will give me 5 plus pi over 2, which is this. More problems. The area between the curves y equal 1 over x. And from x equal minus 1, I need the negative side. So this is the curve. And they want it from -2 to -1 between the curve and the x-axis, which is I'm talking about this area. So what will be the area? The area will be from -2 to -1. I'll do the strip this way. So it will be 0 minus the curve. And that give me what? Minus ln absolute value of x from -2 to -1. That give me minus, what is this? -1 minus ln 1 plus ln 2, which is ln 2. The area of the region closed by these two curves. Yeah, what is this? Yeah, I need to complete the square here. So I have x equal y square minus 4y plus 4 minus 4. That will be y minus 2 square minus 4. To know the vertex, huh? It will be better to know the vertex. And this is what x equal minus y, or y equal minus x, who cares? So this is a parabola. Vertex is 2 and minus 4, something here. It's open to the right. And at 0, it will pass through the line 0, 0. At y equals 0, x equals 0. And they have the line. This is the line. So I'm talking about this area. Okay. And it's very clear, it's better to do it using the dy, because delta dy, dx, I need to split into parts. Okay. So what I will do, also I need this point. This point, I know it. Y, no, I don't need this point. I need from 0, I need this point, which is this. What is this value? This is 0. So I need it from 0 up to this point. How to make this point? Just equate the two. I have x1 and x2. I equate them. I have minus y equal this. So I have y squared minus 3y. Yeah, equals 0. So I have y times y minus 3 equals 0. So I have y equals 0 or y equals 3. So this is y equals 3. This is y equals 3. So I have the integral from 0 to 3 dy. Huh? What is the upper? The upper will be the line. Yeah, the one to the right will be the line, which is minus y minus, let's write x1 minus x2 dy. That's 0 to 3. Yeah. 0 to 3 minus y, I wrote everything in terms of x, minus this, minus y squared plus 4y dy. That give me what? 0 to 3. 3y minus y squared dy. That gives me 3y squared over 2 minus y cubed over 3 from 0 to 3. 0 will not make any difference. That will be 27 over 2 minus 27 over 3 minus 9. That will be 27 minus 18 over 2, which is 9 over 2, which is this. Okay. They're not difficult, but always you need to think about the graph of the function. What about this one? The area of the region enclosed by the two curves. Okay, we have the parabola. It's this parabola. This is up to 6. Okay, and they want the line y equal to. This is the line y equal to. They want this. They want this region. So we do the strip. It will be the parabola minus the line. And they need these points because these will be the border points. So I equate the two. Y1 equal y2. So you have 6 minus x squared is equal to 2. So I have x squared will be equal to 4. So x equal plus or minus 2. So those are, this is y equal to, the line y equal to. Those are minus 2 and 2. So it is the area will be minus 2 to 2. The upper is the parabola minus the line, dx. What is the parabola? 6 minus x squared minus 2 dx. That give me what? 4 minus x squared dx. That's give me 4 x minus x cubed over 3 from minus 2 to 2. That give me 8 minus 8 over 3 minus 8 minus 8 over 3. So I have 8 minus 8, that will be 16 minus 8 over 3. This is not minus, this is plus, sorry. Minus 2 cubed for minus, it will be plus. Minus 16 over 3. That give me 48 minus 16 over 3, which is 32 over 3, which is this. Okay. I have these two lines, tan inverse and the cube root. Okay. Be careful. And I noticed that he did not write it. He wrote it for me as, he did not give me the answer. He gave me the formula of the integral without doing the calculation. Okay, I know tan inverse. This is tan inverse. And they have x cubed. It will do something like this. So I'm talking about these two areas. Yeah, be careful. Yeah, let me make it bigger. So these two areas. M102. Okay. And they are from where to where? This is 0. When the two functions will agree. Yeah. By looking at the functions, I notice at x equal minus 1, I'm getting tan inverse of minus 1. So y1 will be tan inverse of minus 1, which is minus pi over 4, and which is equal to y2. which is minus pi over 4. So this is one answer. The other answer is equal 1. Not easy to, just by inspection, you can get it. I don't think you can solve the two equations to find the point of intersection. So y1 will be pi over 4, which is equal to y2, which is pi over 4. Okay, so this point is minus 1 to 1. Okay. So, and very clearly symmetric about the origin. Yeah, actually the difference between the two functions is an odd function. Yeah, it's an odd function. Yeah, that's not it. Okay. Now, if you look at the answer, the area will be what? A1 plus A2, which is integral from -1 to 0. Now I have the upper is the x cubed minus the tan inverse. So I have pi over 4 x cubed minus the tan inverse of x dx plus integral from 0 to 1, the opposite. Tan inverse of x minus 1 over pi over 3 x cubed dx. But I don't have that answer. This is wrong. -1 to 1, no, it's not correct. The same thing. This one wrong. This one is the accepted one. Why? Because the two areas are the same. A1 is equal to A2. So he said, make it 2 of this or 2 of this. This is the way he did it, the way he wrote it. So sometimes you need to be careful how he write the answer. The area of the region bounded between these two. Very clear. It seems I'm going towards the y. So I have what? I have the parabola open downward, but up to 8. This is 8. This is the parabola. And they have the line. Y equal x, half x, who cares? So I'm talking about this region, which I will do it y-wise. It will be better to do the strip this way. So I need this point. I need the y values. Huh? I need the y values. So I need this y value and this y value. Yeah, and this y value. Okay. Where I have the strip up to here. So I need this point and this point. How to find the points of intersection? Points of intersection. As usual, now I have called x1, x2. So I have x1 equal x2. So I have 8 minus y squared equal to y. I have y squared plus 2y minus 8 equal to 0. So I have y plus 4 times y minus 2 equal to 0. So I have y equal 2 or y equal minus 4. So I have this point, make it minus 4, and this is 2. Okay, so my integral, I'm doing it y-wise, will be minus 4 to 2. The parabola will be the one to the right. So you have x1 minus x2 dy. And that minus 4 to 2. 8 minus y squared minus 2y dy. That give me 8y minus y squared over 2 minus y squared minus 3. No, wait a minute. I have 8. Yeah, I have 8y minus y cubed over 3 minus y squared. Yeah, be careful. The calculation. Minus 4 to 2. Minus 4 to 2. Okay. Yeah, that will be what? 16 minus 8 over 3 minus 4 minus, this is minus 32. What is this? Minus 64, that will be plus 64 over 3. Okay. Minus 16. There's a minus sign here. Okay. So that'll give me what? 16 minus 4, which is 12, minus 8 over 3. Minus 32, minus 16, that will be minus plus 48. Minus 48 times the minus, that will be plus 48. Minus 64 over 3. So I have 60 minus, what is 64 plus 8? That gives me 72, which is 60 minus 24, which is 36. Which is this. Okay. The area of the region enclosed between these two curves, x equal to y square. This is x equal to y square. It's a parabola open to the right. This is the one. What about this one? What is this? I can write it y square minus 2. Okay. Yeah. It will be a little bit complicated. If I equate both of them, 2y square, let me try to find the points of intersection. Maybe that will help me to see the graph. I have x1 equal x2. That will be 2y square equal y to the power 4 minus 2y square. So that gives me y to the power 4 minus 4y square is equal to 0. So I have y square times y square minus 4 equal to 0. So I have y equals 0 or y equal plus or minus 2. Okay. So I have 3 points of intersection at 2 here and at minus 2. So the function will do something like this. It will go like this. Then at 0, it will intersect. And then at 2, it will intersect. Yeah. Then at 2, it will intersect. So I'm talking about these two areas. This area and this area. Everything. Yeah, the points of intersection help me to figure it out. Okay. And it seems the two areas are the same. And we can check. So I need to do it y-wise because the strip will be like this. That will be easy to do. So I have A1 and I have A2. So the area will be A1 plus A2. And what is A1? A1 will be the integral y-wise. I'm making it from 0 to 2. What is the one to the right? Will be it will be x1 minus x2 dy. That give me what? Yeah, 0 to 2 x1, which is 2y square minus y to the power 4 plus 2y square dy. Yeah, let me do the calculations quickly. that minus y to the power 5 over 5, 4y square, that will be what? 4y cubed over 3. This is from 0 to 2. That give me what? 2 to the power 5, which is minus 32 over 5, plus 4y cubed, 32 over 3. Now a2 will be the integral from minus 2 to 0, same thing. Yeah, so actually I can make it in one step, but it's okay. It's now the parabola, which is 2y squared minus y to the power 4 plus 2y squared dy, which is the same calculation. This time from minus 2 to 0. Yeah, it actually should be the same. By the way, this is what? 3 times minus 3, 32, plus 5. So I have 2 times 32, 64 over 15. Okay. Yeah, this will be 0 minus, like the minus 2. That give me 32 over 5. Yeah. Minus 32 over 3. So I have the same answer. This minus 64 over 15. So it will be 64 over 15. So the area total will be A1 plus A2, which is 128 over 15, which is this one. Okay. It's a matter of English. Not that difficult. Okay. The area of the region enclosed by this is given by this integral. You want me to do it in yeah, as an integral. Let me grab the functions. It's always good to grab the functions. I have 1 and 2. This is 1 and 2. And this is the line. This is the absolute function. Absolute value function. Okay. What I have, this is 1 and 2. And I have the line y equal half x plus 3. Half x plus 3. When the area of the region bounded between these two curves. Yeah. When the two curves intersect, I need to solve them. Y1 equal y2. I have absolute value. How to do this? Okay. Yeah, this is 1. So at x equals 3, at x equals 0, y equal to 3. Yeah, y equal to 3. And the line will do something like this. Okay, let me find the point of intersection. I equate the two. How to solve that? I take it cases. If x is greater than or equal to 1, so I have this. It will be 2 plus x minus 1 equal half x plus 3. Multiply, that means what? X plus 1. Not x plus 1. I have, take this to the other side, half x equals what? 3. 2 minus 1 is 1. That's equal to 2, so x equal to 4. And if x is less than or equal to 1, then I have 2 minus 2 plus 1 minus x. 2 plus 1 minus x equal half x plus 3. So I have 3 cancelled, so I have x equals 0. So x equals 0. This is another point of intersection. Okay. So the two lines, they agree here. This is 3. And the line will do something like this. Yeah, let me graph it better. Now it's very clear how the graph will be. So I have a parabola here up to 3 and from 1. Yeah. No, actually not the parabola, I mean this line and the other line. Yeah. The other line will do something like this. So this is 0 and this is 4. So I'm talking about this area. Okay. So the area actually I need to split it in 2 parts. So I have one part is here. Yeah. This is one part. So I have 2 areas, A1 and A2. Yeah, and this point is 2. I know this point is 2. Or this point is 1. No, sorry, it's not 2. It's not 2, it's 1. The x minus 1, so it's 1. Okay. So this is what we have. So it is, the area will be integral from 0 to 1 of what? The line minus the negative part of the absolute value. Be careful. This one is the negative part. So this will be 2 plus 1 minus x, which is 3 minus x. And this one, no, this is not y1. This the negative part of that. So this one will be y equal 2 plus x minus 1, which is 1 plus x. Okay. So now the area, yeah, let me call this y3 and this is y4, where y1 will be y3 if x is less than or equal to 1, and y4 if x greater than or equal to 1. Okay. So now my area will be the integral from 0 to 1 of y2 minus the negative part of the absolute value, which is y3, dx, plus 1 to 4 y2 minus the positive part of the absolute value, which is y4. Let me do the calculations. He doesn't want me to find, he just wants me to find the format. Y2 will be 1/2 x plus 3, and y3 is what? Minus 3 plus x dx. And from 1 to 4, y2 half x plus 3 minus y4, which is minus 1 minus x dx. So that gives me what I have from 0 to 1, 3 over 2x dx. From 1 to 4 will be what? 2 minus half x dx. Which is this? Very clear, it's this. Yeah. It's not difficult, but yeah, it needs some calculation. Be careful with the calculation. The area of the region bounded between the curves, this. Okay. Very clear from the question that I should, I need to think of it as y, in terms of y. X equal minus y squared. So the parabola is this one. Opens to the left. X equal, yeah, is at 0. It's minus 4. Yeah, we'll do something like this. The line. And I will do the strip this way, which is always will give me one area. And this is, he wanted y equal minus 1 and 2. Doesn't want all of it. Y equal minus 1 is this one minus 1 and y equals 2. I'm not sure. Yeah, let me check. If y equal minus 1, yeah, that x is y plus 4. X is y plus 4. So if y equal minus 1, no, this is not the point of intersection. X equal, sorry, yeah, y plus 4. Okay. And the line y equal minus 1. Where is minus 1? Minus 1, it gives me minus 5. Where is the point of intersection? Let me equate these two. Minus y squared equal y plus 4. That doesn't give me the point of intersection. It doesn't give me any. It will be y squared minus y minus 4 equals 0. I cannot solve it. Okay. Yeah. 2, also 2 is not the point of intersection. Y equal 2, give me x equal 6. And in the other one, it's x equal minus 4. So the point of intersection, if you want to equate the two, x1 and x2, so I have minus y squared equal y plus 4, that I have y squared plus y plus 4 equals 0. Wait a minute, what am I doing? Yeah, the mistake, this is y equal x minus 4. Yeah, will be something like this. So there is no point of intersection. Yeah, I make it the other way. Okay. Yeah, this is explained. There is no point of intersection between the two. Well, you notice, minus y squared equal y plus 4. So y squared plus y plus 4, which is y squared plus y. You add half of this plus 1 over 4 plus 4 minus 1 over 4. So it's always positive. This one. 15 over 4. So it's always positive. So there will be no point of intersection. They will not intersect. And they need this. I need y equal minus 1. When minus 1, this is minus 4. Minus 1 is somewhere here. No. X equal 0, that is minus 4. Yes, you're right. This is minus 1. Y equal minus 1. Y equal minus 1. It will be something like this. And y equals 2. Y equal 2. Minus 1, give me what? Minus 5. Y will be minus 5. X equal, no, I need to check this. Y minus 1, X will be 3. Y equal minus 1. Here, this one. Y equal minus 1. X will be 3. It will be something like here. Okay. And in this curve, if y equal, that means this one. This is y equal minus 1. Y equals 2. That gives me 6, and it will be still negative. Y equals 2. X will be negative. Yeah, X will be negative, yes. Something like this. This is Y equals 2. So I'm talking about this area. Yeah, so the area will be from minus 1 to 2. Yeah, sometimes you need to be careful about the graph. Yeah, my mistake, I make it minus X, not X, okay. So this is the area where I have the line minus the parabola. The line is what? In terms of X. So I have X2 minus X1 dy. That will be minus 1 to 2. X2 is what? Y plus 4 minus square plus y square dy. So I have y square over 2 plus 4y plus y cubed over 3 from minus 1 to 2. That give me what? 2 square 2 plus 8 plus 8 over 3 minus. So with the minus 1, that will be half minus 4 minus 1 over 3. So I have what? 6, 10, 8 over 3. 10 plus 8 over 3 minus half plus 4 plus 1 over 3. This is 3 plus 7. 3 plus 7. 3 plus 4 is 7 times 10. 17 minus half, which is 34 minus 1 over 2, which is 33 over 2. Which is this? Yeah, sorry about the calculation. Yeah, sometimes you need to see the graph. So this is what I'm talking about, and this will be the strip. Okay, we'll make it y-wise. Y equal this, and y equal this. Yeah. This is y equals 6 minus x squared, and this is y equal minus 2x plus 3. Yeah, be careful. This is parabola. Okay. This is a line. Okay. At x, yeah, point of intersection. Let me find point of intersection. It means this is y1, this is y2. y1 equals y2. So I have 6 minus x squared. So I have x squared minus 2x minus 3 equals 0. I have x minus 3, x plus 1 equals 0. Am I right? Yeah, x squared minus 3. Okay. So I have x equal minus 1 or x equal 3. This is what I'm looking for. Minus 1 and 3. And these are the points of intersection. So when x equal minus 1, this is minus 1. This is minus the square root of x, minus square root of 6. This is square root of 6. Yeah, to be sure, where am I? So minus 1 is here. So the line is at x equals 0, it's 3, where 3 is here. And at x equal, this is 3. At x equal 1, at x equal 1, it's 1. So this line will do something like this. No, this is my line. And this is at minus 1. This is at minus 1. And this is at 3. Okay. And they'll take the strip this way, which is the problem minus the line. Very clear. So the area will be minus 1 to 3. The parabola, which is 6 minus x squared, minus the line, which is plus 2x minus 3 dx. That gives me what? Minus 1 to 3. 3 minus x squared plus 2x. Yeah, let's make it. Minus x squared plus 2x plus 3 dx. That gives me minus x cubed over 3. Yeah. Plus x squared plus 3x. That from minus 1 to 3. Minus 27, that will be minus 3 plus 9 plus 9. Minus 1. That will be 1 over 3 plus 1 plus 3. Not plus 3, this is minus, sorry. 1 minus 3. So that give me what? 15. This is minus 2 with the plus 2 minus 1 over 3. So you have 17 minus 1 over 3. Did I do a mistake somewhere? Yeah. X minus x squared minus 2x plus 3. This is correct. Minus 1 to 3. Let me check the calculation. Minus x squared plus 2x plus 3 minus x cubed plus x squared plus 3x. 3, it says what? This is not minus 3. This is minus 9. Sorry. Yeah, because it's minus 27. That will be 9. Sorry. So 9, that will be 11. That will be 9. That will be 11. So I have 33 minus 1 is 33 over 32 over 3. Yeah, matter of calculation. I'll finish by this question, which is a nice one. Be careful in the graph. Y equal cosine x. This is cosine x. I'm care about 0 to pi over 2. But what about sine 2x? It's not sine x, it's sine 2x. It means it will do what? Yeah. At pi over 2, it will be 0. It will not be 1. So it will go until pi over 4. This will be your 1. Huh? You know what? Let me graph. This is first. And then I graph the other one. Yeah. I want to graph y2. This is what? At pi over 4. This is sine. And this is my pi over 4. And this is pi over 2. Because I have sine 2x. And then I have the y equal cosine x. Y equal cosine x, which will do something like this. Let me make it bigger. Yeah. This one will do something like this. Okay. And he wants the region enclosed by the curves x equals 0. So I have this x equals 0. This is x equals 0. And x equal pi over 2, which give me this. So I have these two areas. I don't know if it is very clear or not. So I can do something like this. So I have this area and this area. These are then enclosed by these four curves. I have x equals 0, x equal pi over 2. This one is not included because it's not enclosed for x equals 0, x equal pi over 2. Actually, yeah. So this is what are included. I have this is A1 and this is A2. So my area will be A1 plus A2. Now we need to do the calculation. In A1, oh, by the way, this is pi over 4. Huh? So A1 will be the integral from 0 to pi over 4. What is the upper? The upper will be the cosine. Huh? It will be cosine x minus sine 2x. Okay. Or let me say it y1. Yeah, the cosine x is save time. dx. That will be sine x plus half cosine 2x from 0 to pi over 4. Okay. Yeah. Actually, you can check and when they intersect. Sine 2x is what? 2 sine x cosine x. So I can take cosine x common factor. I have 2 sine x minus 1 equal. Yeah. I can take cosine x So this is not pi over 4. No. Sorry, this is not pi over 4. Let me check the point of intersection. So this is not pi over 4. Sorry for that. Yeah, I need to check the point of intersection. I equate the two. So now this will be cosine x minus 2 sine x cosine x. So equal to 0. So I have cosine x 1 minus 2 sine x equals 0. So I have cosine x equals 0 and sine x equal half. So x equal pi over 6, not pi over 4. This is pi over 6. Where they will intersect, it will reach 1 here, which is pi over 4. But this is not the point of intersection. This point of intersection is pi over 6. And x equal pi over 2, which they intersect at pi over 2 also. So this is another point of intersection. Okay. Yeah, so this is pi over 6 from 0 to pi over 6. And this is pi over 6. Sine will reach 1 at pi over 4. Sine to x will reach 1 at pi over 4. But the point of intersection, this is what I'm looking for, which is pi over 6. Okay. Now, I do the calculation. Yeah. That will give me what? Sine x. That will be cosine x. Substitute sine pi over 6, which is half. Here I have cosine pi over 2. So it's half plus 1 over 4. That give me minus 0. Wait a minute. Minus 0. Here I have what? Plus half. So I'm getting 1 over 4. This is the first area. The second area will be the integral from pi over 6 to pi over 2. Now the difference, the sine function minus the cosine function, sine to x minus cosine to x. Integrate, that will be minus half now. It will be minus half cosine to x minus sine x from this pi over 6 to pi over 2. That give me what? Substitute pi over 2, you get pi. Cosine pi is minus 1, that will be half. Sine pi over 2, gone, 0. Minus. With pi over 2, it will be cosine pi over 3, which is minus half. Half times minus half minus 1 over 4 minus half. That give me what? Yeah, did I do a mistake? Pi over 2 give me half minus. Here I have what? Pi over 6. Pi over 3 minus 1 over 4. Pi over 2. Pi over 6 to pi over 2 minus pi over 2 minus half. Integral will be sine to x minus cosine x. How to integrate this? Minus half cosine to x minus sine x. There's something wrong with the calculation, it seems to be. Pi over 2, it will be by sine pi over 2. Yeah, here is 1. Sorry. Yeah, sometimes be careful with the calculation. Half sine pi, which is minus 1, minus 1 over 4, minus half. That give me what? Minus half plus half, that will be 1 over 4. So my area will be 1 over 4 plus 1 over 4, which is half. It's a matter of calculation, yeah. I think I will stop here. Yeah, we did good number of questions, and sometimes we need to be careful with the calculation, with the graph, with all of these things. Yeah, but I think to give us an idea of what are we doing. Yeah, let me stop the recording. Thank you.